Hey guys, so today we are talking about finding the probability of dependent events. We talked about independent on Wednesday, now we're going to talk about dependent. So we talked about how independent means it doesn't affect anything else, so the first event's not affecting the other one. So if you have a dependent event, that actually means that the outcome of the first event affects the outcome of the second event. So how do we solve independent event problems? Well, we actually have the exact same formula that we use for independent events. So the probability of A and B equals the probability of A times the probability of B. So these letters just stand for whatever action is taking place in an event. So that just means the probability of the first action times the probability of the second action is going to find the total probability for A and B. Please keep in mind, whenever you see the word "and," you are going to multiply. So the difference between independent and dependent events. Independent events, they do not affect each other. It doesn't matter what happens in the first action, it's not going to affect the second action. In a dependent event, they do affect each other. So whatever happens in your first event will affect what happens in your second event. And here's what I mean by that. So here in example 1, I want you to draw this. We have 3 red cubes, 2 green cubes. I want you to pause, go ahead and draw that. So what we're going to do here is we're going to find the probability of picking red and green without replacement. This right here, without replacement, that's going to clue you in that it's a dependent event. So whenever it's dependent, you're going to see the words without replacement. And here's what I mean by that. So here, I actually have some green and red cubes, and I actually made a mistake here, sorry. There should be 3 green and 2 red cubes that you draw on your notes. So we want the probability of picking a red and a green. Well, if we look at what we have here, okay, first of all, we have to find the probability of red, and we have to find the probability of green. So the probability of red, we have 5 total cubes, so we know our denominator is 5. That's our total amount we're working with. And then 2 of those are red. So the probability of picking a red would be 2 out of 5. Well, let's say we do pick a red. This says without replacement. So that means this red's going to go away and it's not coming back. So when I find the probability of green, again, I have to look at my total. Well, here's the thing. Since we didn't replace the other cube, we now have a new total. So we have 1, 2, 3, 4 cubes. So our new total is 4. So our denominator actually has to be 4. And this is what's changing with a dependent event, is sometimes the numerators and denominators change. So now we have to see how many green cubes we have to get our numerator. And we have 1, 2, 3 green cubes. Now that we have the probability for red and the probability for green, we can multiply. Because when we find the probability of one event and another, we have to multiply. So when we multiply fractions, numerator times numerator, 3 times 2 is 6. And then we do denominator times denominator, and 5 times 4 is 20. Please keep in mind, you always need to reduce your fractions. So somewhere on your notes, I want you to write, and I'm going to write it up here, reduce fractions. Do not forget to reduce and simplify at the end of every problem. So, 6 and 20. I can divide both of those by 2. And my simplified fraction is 3 over 10. So the probability of picking a red and a green without replacement is 3 over 10. Okay, let's do another example together. So, example 2 says the probability of a green and a green without replacement. So on example 2, I want you to draw an arrow to your picture you drew before, because we're going to work with the exact same colors, the same cubes, same numbers, everything. Okay? So, we want to find probability of green and green. So we have to find the probability of green. Then we have to find the probability of picking another green. And again, this is without replacement. Without replacement tells you it's a dependent event. What happens first is going to affect what happens second. So, for our first one, we know that our total is 5. We have 1, 2, 3, 4, 5 cubes. Then we have to see how many are green. 1, 2, 3. 3 of those are green. So let's say that we did pick a green cube. This is without replacement. So it's gone. It's been picked. We don't replace it and put it back. So now we have to find the probability of picking a green again. Well, now we have to look at our total. We have 1, 2, 3, 4 cubes total that are left. And we have to see how many of those are green. 1, 2. 2 out of 4 are green. So see how whenever we don't replace it, it affects the outcome of the second. It affects our numbers here because we have to change it based on what's left. Now, whenever we multiply, I like to reduce first before I multiply. We didn't have to do that in example 1 because these were already in simplified form. But here in example 2, I can reduce 2 over 4. So I'm going to go ahead and reduce that. That equals 1/2. 3/5 is in reduced form, so I have both fractions in reduced form. And then I have to remember, when I find the probability of one event and another, and means I am multiplying. So I need to multiply 3/5 times 1/2. Multiply my numerators, I get 3. Multiply my denominators, 5 times 2 is 10. And I actually get 3 over 10 again. Now, I want you to try a couple on your own. Let's say you have 4 blue cubes, 3 yellow, and 1 pink cube. Without replacement, I want you to find the probability of selecting a blue, then a pink, and I want you to pause and I want you to go ahead and solve that on your own. Okay, so if we're going to find the probability of a blue, then a pink, first we have to find the probability of blue, and we have to find the probability of pink. So for blue, we have to look at our total. We have 1, 2, 3, 4, 5, 6, 7, 8 cubes. So we have a total of 8. That goes in our denominator. Now we have to see how many blue we actually have. We have 1, 2, 3, 4 blue cubes. And I'm just going to go ahead and reduce that. That's 1/2. Now, let's say I actually did select a blue cube. And this is without replacement, so it just goes away. Now, for my pink, I have to see how many total cubes do I have left. Well, I have 1, 2, 3, 4, 5, 6, 7. And how many of those are pink? 1. That's in simplified form. I can just leave it the way it is. So now I have 1/2 times 1/7. 1 times 1 is 1. 2 times 7 is 14. So the probability of selecting blue, then pink, without replacement is 1 over 14. Okay, I want you to do this next problem on your own. Find the probability of selecting a yellow cube and then another yellow cube without replacement. Go ahead and pause this and work that out on your own. Okay, so if we're finding the probability of selecting yellow and then another yellow, we have to find the probability of yellow and the probability of yellow. So with all cubes here, I have a total of 8. And then I have to see how many are yellow. 1, 2, 3. 3 of those are yellow. So let's say I did select a yellow. Without replacement, that means that's going to go away. So now it has affected what's going to happen in my second event. So now for probability of yellow, I have to find my new total. 1, 2, 3, 4, 5, 6, 7. I now have 7 total cubes. And now I just have 2 of them that are yellow. And the same formula here. If I find the probability of one event and another, I have to multiply. These are already in reduced form, so I'm just going to go ahead and multiply. 3 times 2 is 6, and 8 times 7 is 56. And I'm going to rewrite that down here. Alright, 6 over 56. That is actually not in reduced form. So I'm going to go ahead and reduce that. And we can divide both of these by 2. 6 divided by 2 is 3. And 56 divided by 2 is 28. That cannot be further reduced. So the probability of selecting a yellow and another yellow without replacement would be 3 over 28. And I want to end this video by giving you guys a little saying. This little saying says, a fraction for every action, multiply the fraction. So I want you to keep that in mind with independent and dependent events. A fraction for every action, multiply the fractions. So that means if you have 2 events happening, you'll find the probability, which will be a fraction for the first event, find the probability, which would be a fraction for the second event, then you're just going to multiply those 2 together. So I want you to write that somewhere on your notes. Make sure you you can write a small summary at the bottom, and be prepared to work with our dependent events in class on Tuesday. I hope you enjoy your 3-day weekend, and I will see you on Tuesday.